This is the Overfill Prevention presentation, the 9th out of 12 training modules in the Underground Storage Tank Class A and B Operator Training Program offered by the New Hampshire Department of Environmental Services. This presentation is narrated by retiree Spruce Wheelock.
In this module, we're going to talk about the overfill devices, the delivery methods that are currently being used. We also look at some of the approved devices and the overfill limits that you can fill your underground tanks to, and some other examples of overfills hopefully we will not see many of in the future. Now, all regulated underground storage tank are required to have a device that either stops, restricts, or alerts prior to wetting the inside top of the tank. And people go, Well, here's an example of an underground tank that's being removed. It is a double-wall tank. Granted, it could be either the 300 or the 360. We allow both types of designs currently. A 300-degree wrap means that the very top of the tank is not double-walled. The 360 would be double-walled all the way around, except if you see all these bungs, what they call, or connections to the top of the tank, and if you look close, you can see all the staining running down from these connections down the side of the tank. And that is because all these connections at the top of the tank are not double-walled. All right. Even with a tank that's 360-degree wrap, all the fittings are not double-walled. And so in today's society with our underground tanks here in New Hampshire, most of our leaks and contamination we get are from connections. Hence, that's why we do not want to wet the inside top of the tank where these fittings are, because that's where we're getting our contamination currently today. Causes, well, there's plenty of causes, mostly human error. Volume calculation. Well, for example, if you got a heating oil tank or a gasoline tank, and you say, well, I'm using X amount of gallons or selling X amount of gallons, and I'm going to get a delivery another day or two. So I'll figure I'll need to have, by that time, I need to have enough product delivered to fill the tank up. Well, sometimes it happens that there'll be an accident out on the street, and so you didn't sell as much product as you had planned, or that the heating oil tank didn't use as much fuel because all of a sudden we had a heat wave. And then the driver drives up with a truckload of product, and it's too much product to fit into the tank, and a possible overfill happening. Method. Using the wrong method to deliver to your tank, and we'll go over that in detail. Deliver to the wrong tank. You wouldn't believe, every couple of months we get a phone call saying the delivery company just put diesel into the gasoline tank, or vice versa. It happens. We're humans. It happens. We do make a mistake. And by the way, I've never made a mistake in my life. Yeah, right. Okay, well, we're human. It all happens. So we're trying to prevent a problem if it does happen. Installation. We need to make sure that overfill devices are installed, and we also need to make sure that they're maintained. And that's why the state of New Hampshire, on our state inspection, how often is it the state does the state inspection, guys? Hint, hint, every 3 years? Well, on our state inspections, we do come out and make sure that you remove the overfill device so that we can make sure that it's there and it's maintained and working properly. First of the two types of delivery methods. First one is gravity. Typically you have a tanker truck that would drive in, connect up his 4-inch hose to your tank, and drop product around 300-400 gallons a minute into your underground tank. Now, here we have a loose connection where they just pour it in, such as maybe a used oil. Somebody is changing oil in automobiles in their service station. Well, they just roll that tank out, that drum, out to the underground tank and just open it up and pour it in. That is an acceptable method of delivering product to your underground tank. Now, with your typical tanker truck, he, like I said, had a 4-inch hose, 20 feet long, holds 14 gallons. Here's a red flag for you. How many gallons is your spill bucket designed to hold? Bing, bing. You guys that have been to this training before will remember 5 gallons. So that spill bucket right here, where he is filling this tank, is designed to retain 5 gallons only. Well, if he's got 14 gallons in his hose and he accidentally overfills the tank, he's got all his product up in the hose. Now what is he going to do? Well, it's 2 o'clock in the morning. Nobody's here. I'll just disconnect it and let it run out on the concrete pad. Well, that happened in the old days and hopefully never again. So red flags are you got to make sure, number one, you keep your spill buckets clean because it can only hold 5 gallons. And number two, we need to make sure that we can fit the product into the tank prior to delivery. Second type of delivery method is your pressure delivery method. We call it a pumped or pressure delivery. Somewhere around 30, 75 pounds of pressure is typical. And you could be up to 100 gallons a minute delivery. This type of pressure delivery, quite often you'll see, is for home heating oil, but it could be for many other scenarios, such as this truck right here. This truck here is designed for your pressure delivery, pumped in right here for heating oil, but it's a multi-purpose truck. It can do gasoline, diesel, and heating oil, depending on what product needs to be delivered. He can also deliver with that 4-inch connection, 4-inch hose, because he's got his gravity drop here. And again, he can pump in with like the heating oil or diesel along this scenario. Now, he can also do gasoline because he has this stage 1 vapor recovery attachment here where the gasoline is dropped into the tank and the vapors then returned back to the tanker truck. Here we have a tight connection to the fill, which is fine. And again, you can still do loose deliveries to your underground storage tank. That is acceptable in many cases. But say pumped 30 to 75 pounds of pressure. Now that people have been to this, some of you have been to this class before, what is your designed pressure that your underground tank can withstand? Raise your hand. Oh, I see one. Yeah, right. Okay, your underground storage tank is designed to withstand a maximum of 5 pounds of pressure. After 5 pounds of pressure, you could split the tank open, the seam could break, whatever. The tank is only designed for 5 pounds. So if you can pump in at 30 to 75 pounds of pressure, red flag. If things don't go properly, they can easily cause your tank to release and split it wide open. Again, all regulated underground tanks in New Hampshire are required to have an overfill device to be one of these methods, the stop, the restrict, or the alert hint. So it has to be one of those. And we'll go over those types of devices here in a minute. Has to be accessible. How else is the state going to come out and inspect it? How are you going to maintain it if it's not accessible? Has to be compatible with a delivery method. Now, we just talked about 2 different types of delivery method, pressure and also the gravity. So depending on the type of device, it has to be compatible with whichever delivery method you're using. This is the one people generally don't think about, and that is register your primary device. Is it a stop, restrict, or alert? Which one? Register it on the registration form. Why is that important? I usually have somebody ask. Well, that way, if it's you register it with us, you know what type of device you have, and also the delivery company can go on our website, which is the One Stop. It can go through the registration information and find out which device that you have and what type of delivery that they can, or method of delivery they can deliver to your underground tank. So it's very important. All right, the devices. We have your typical flapper valve, which is on your fill drop tube. The second type that we'll talk about is the restrictive, and that is your ball float, and that's on your vent. And the third device that we'll go over is your audible visual alarm. So those are the three. Your flapper valve, which is your shutoff, complete shutoff device, your ball float, which is your restrictive, and your, of course, the audible visual alarm. Flow stop device. In other words, it totally shuts off flow. Now, we call it a flapper valve because generically here in New Hampshire, most of the ones that we have installed have this little float on the side, kind of like a flap. So we call them a flapper valve. Normally in class, I'd hold you up a device and show you how it all works, but I can't do that by this method of online training. This float does float up and down, and when it does float up, we have a little cutaway here. You can see this flap in here. It flops down and shuts off the flow to your underground tank. So as the product comes up, the float comes up, allows the valve to shut. Now remember, this is a complete flow shut-off device. And he's got how many gallons in his hose? 14. So if it completely shuts off, he's got 14 gallons in his hose that's stuck there. Well, this is what they call a two-stage overfill device. So the first stage is this flow comes up, releases this flap, and it shuts. Okay, it slows that product down from that 400 gallons a minute down to 5 gallons a minute, because the second stage wants you to be able to drain that 14 gallons out of his hose at a rate around 5 gallons a minute, and then that shuts off. So that's a two-stage device, complete flow shut off. And so what I usually ask the class, okay, what percentage, how full can we fill that tank? Speak up. Darn, I can't hear anybody. Anywho, what it's supposed to be and set at, that's what we have to verify, and that's why we come out and do state inspections, to be set at maximum 95%. So if you have an underground tank, you order product, that's where the human error comes in, and you say, well, gee, I got a 10,000 gallon tank, I'm going to order 10,000 gallons. Well, no, you can only put in 95% of that 10,000 gallons into your underground tank. So you got to be aware what overfill device you have and what product or what level of product that you can, or how much product you can put into your underground tank. So that's where some of that human error. So hint, hint, keep in mind, flow shut-off device, complete flow shut-off device is set for 95%. Okay. Different manufacturers. We have an OPW, which I was just talking about, is one of the most common that we see in the state of New Hampshire. We have MCO Eaton. Now this device is a little bit different because this float is not out on the side. It's actually looking similar to this EBW. This just has a cover over it. It looks like under this cover is like this. It's two floats. Okay. First float is for your first shut off from your product coming at 300 or 400 gallons a minute. And then the second stage, the second flow here shuts at 5 gallons a minute off. It's just a different manufacturer, different type. And if you're doing your monthly inspections as an AB operator, this is a filled drop tube. You would look down your drop tube, and if you see this indentation, which I would show you in class, but I can't, it shows that there is a blockage of some sort here about halfway down. It looks like the drop tube, and what it is indentation in the drop tube, which I can't show you because I don't have it here, that directs the flow. So if he's doing 300 or 400 gallons a minute, it comes down through the tube here, hits this direction here, and hence it goes back and slams that valve shut. Remember the little flapper that I was showing in the previous screen? It slams that valve shut, and it's just to direct the flow to make sure that the valve shuts properly. Restrictive device. Remember, we just talked about flow shut-off device. Now we're going to talk about flow restricting device. We call it a ball float. They're usually installed on vent locations or a number of different places within the tank that tie into the vents. And the way ball float works is that you have product in your tank, and you have a ball, and as you fill the product into your tank, it floats the ball up and plugs this vent tube. So if you think about filling an underground tank, you dump product into the tank, and all the vapors that are in the tank now, the air, the vapors, need to get out of the tank, so are displaced by the product. So all the vapors now are going up this tube until the ball comes up and plugs it. So we were getting 300 to 400 gallons a minute during the delivery. Now we slow it down to 5 gallons a minute. So the vapors now are going out through this little bleed hole at a rate about 5 gallons a minute. Now this is only a restrictive device, being that there is no valve there to shut off. So you keep on filling that tank at 5 gallons a minute till this is all filled up. Past here, fill that product full of vent, line full of product, and out your vent and all over the ground, etc. So it is only a restrictive device. We're not allowing ball floats on any proposed new system. Now, being restrictive, I usually try to ask, I say, what level can we fill this tank and feel safe about? What is required? What percentage? Somebody raised a hand over there, I think I can see. If you said 90%, you are absolutely correct. So when you order product and you have a ball float restrictive device on your tank, you can only order and put into the tank 90%. All right. For example, like I said, you had a 10,000 gallon tank and you want to put 10,000 gallons in it? No, you can only put 90%. So you can only put 9,000 gallons into that underground tank before this ball float closes. Also on top of that, if that ball float fails, and which this date is just around the corner, or has already got here, is October 13th, 2021. If it fails, so the ball breaks out of it, something breaks, and you need to replace it, or it's not set properly, you currently can replace it. But after that October date, you can no longer. You would have to come up with a different type of overfill device other than a ball float. We already talked about the flapper type, and we'll talk about the alarm next. So keep that in mind if you have to service or replace your ball float. The third type, we talked about the first was your flapper valve at 95%. We talked about the restrictive ball float at 90%. Now we're talking about the audible visual alarm. Here's an example of a Veeder-Root sensor. This is what we call an automatic tank gauge probe for a typical Veeder-Root system. Whereas this float here tells you the product level, the lower float tells you if you've got water in your tank. It also gives you your inventory of how many gallons are in the tank. It's a multi-purpose type of float system. In this particular example, we have a Veeder-Root box with an audible horn and a light. Here's an Omtech, has a horn, has a light. Now you have to, per regulations, have both the light and the horn. Heaven forbid that you hire a delivery company and the driver drives up and he's both blind and deaf. Ha, 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 ha. I can hear you laughing now. So lights burn out, horns get plugged up with bees. We need both. Okay. I also pushed for the regulations because in the old days, the light was okay if you could see it and find it. So we require that there be a sign explaining this is an overfill device. I had a scenario once where I was inspecting at a school. And I asked the AB operator, we were standing there, and I says, you got registered an audible visual alarm for overfill. I'm looking around. I don't see it. I'm the inspector. I'm looking for it. And he says, well, see down there 300 feet so on the side of that school building there? Yeah. You see that little red thing down there? That's the alarm light. okay. But if I was a new delivery driver and I saw that light go off to a school, what do you think he's going to think? Or I'm going to think? Ding dong. Hey, it's a recess. School's out. Now, why would he tie 300 or 400 feet away on the side of a school building with the underground tanks? So if there's a sign there explaining what that device is, then at least the driver knows it's not recess or a school bell. It is for the audible visual alarm. So we need to make sure we have an alarm system. Now, how full can we fill this type of underground tank with the audible visual alarm? Percentage, guys. What is it? If you said 90%, ding, 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 you are correct. So again, we're setting, if that 10,000 gallon tank and you want to fill it, you can only fill it to 9,000 gallons because that's 90%. So keep in mind, an audible visual alarm needs to be set at 90. And again, the reason for 90 is when the alarm goes off, oh, the driver needs to do something. While the tank is still being filled, I need to shut the product off and stop the delivery. So we got to give the driver some time to shut down the delivery prior to wetting the inside top of the tank. That's the whole reason why we have it at 90. Otherwise, if the alarm went off at 100%, well, he'd already be overfilling the tank before he could run and close the valve. That's the reason behind that. If on your registration form, you register as your overfill, primary overfill, as the audible visual alarm, that visual light needs to stay on until you manually reset it. Because if it flashes on, like in the old days with the regulation, if it just flashed, it met the requirements. Well, if the driver's not staring at that light, would he see it flash? No. And the same with the audible visual. With the audible. 10 seconds. Before, if it just goes beep, oh, that was the overfill alarm. Well, if a truck drove by and backfired or whatever, was that or was it the overfill device? I don't know. So we came up with a minimum 10 seconds. So the driver knows, I hear it, I see it, okay, I got to shut down. So for a regulated primary overfill device, these are the minimum requirements, if that's what you're relying on. Also, if your primary is that audible visual alarm, you need a separate light and horn for each individual compartment or tank. Why? Well, let's say you have one horn and one light, and you have 4 tanks or 5 tanks. Well, I'm going to drop diesel right now, and I'm going to fill the heating oil tank at the same time because time is money. Well, if I only have one light and horn, when that light and horn goes off, which tank is full? I have no idea. So that's why we require, if you're going to fill more than one compartment / tank, you need a separate light and horn so you know which tank is full that you need to shut down. This is fairly new in our regulations, day tanks. Day tanks also required to have overfill devices. And when the state inspector comes out, you need to inform them, yes, we have a day tank, and the contractor needs to take these apart and test them. The reason why we're checking day tanks nowadays, it's a fire code regulation, is we've in the past had some of these day tanks fail, and something about heating oil running down the hallways of a school tend to get the townspeople a little angry when the school is shut down for a month or two for cleanup. Doesn't go over well. So we want to make sure that the day tanks are working properly, so therefore we do inspect them when we go out there for the 3-year inspections. The other item to keep in mind is 1, notify the contractor that you have a day tank. And who would have a day tank? Generally, day tanks would be attached to somebody that has a generator or a heating oil system. Those are the general rules where you'll see a day tank installed. So if you have either a heating oil system or an emergency generator, you might and likely have a day tank associated with that that you need to investigate and maintain. Testing these devices, these overfill devices. As of December 2017, and then every 3 years after you've done the test, you need to verify proper operation and installation. Was it set at the 95% or the 90%? And then every 3 years thereafter, like I said. And what's good about our state inspections are, how often do we do our inspections? Every 3 years. So you're very lucky that you may be able to save a few dollars if you get onto the schedule where the state inspector comes out, because we do have the contractor or yourself remove these overfill devices when we do our state inspection, and we can verify and make sure that it's set at the 90 or 95% and it's working properly for you at that time. Above ground tank device that we do allow, but it's only by waiver. Okay, keep that in mind. We allow this type of device, and it's only by waiver, and we talk about waivers in a different module. And the reason we require a waiver is because it is an overfill device. The manufacturer says we can use it in underground tanks. But if there's ever a problem, we want to know where they're installed so we can contact you, the facility AB operator, saying we have a problem with this type of device and we need to research or possibly remove it and replace it with something else. Why would they want to use this type of device? Well, it's usually attached to smaller underground storage tanks, like 1,000 gallons or 15 or 2,000 gallons, like a heating oil tank or a kerosene, possibly a small diesel tank, because they do a pressure delivery. And it may be an older tank with limited access, so they want to use this type of overfill devices. Well, red flag here is this is looking down your drop tube, and there's your flapper. Now, most delivery, if not all delivery companies, will want to stick the tank before they drop product into your underground tank. Well, this is where they'd run the stick down through to stick your tank. Well, the inventory stick cannot fit down past this valve into your tank to stick it to see how much product is in the tank. So you need another method to be able to determine how much product's in the tank so the delivery driver can deliver to this type of setup. But remember, it's only by waiver only. And it's set again at 90% because we have to rely on the driver operation, and it's an overfill device for above ground tank system. Compatibility. Here we have the Audible visual alarm. This is the only of the three device that will work for both delivery methods, which were what? Gravity and pressure. So hint, hint, the only type of overfill device that works with both gravity and pressure is the Audible visual alarm. Now the problems that we have with flapper valves. It can only be by gravity only. And it also has to have a tight connection. And we cannot have ball floats. Huh? What do you mean we can't have ball floats? Well, let me see. Let's look at this example over here. Our flapper valve. Okay, here's our ball float. Our flapper valve is set at what percentage to be completely shut off? I hear 95%. You're right. Okay. Ball float, what percentage? I hear 90%. Okay, so product fills up here. Ball float closes at 90%. All right, but we're supposed to be relying on the flapper valve. Okay, we keep filling the tank. From 300 to 400 gallons a minute to 5 gallons a minute. Well, at 5 gallons a minute, as this float comes up, would not close that flapper valve. Remember we had that big flap there and we were delivering at 300-400 gallons a minute with the indentation here to slam it shut? Well, at 5 gallons a minute, there's not enough product flow here to slam that valve shut initially. Okay, so therefore, valve is being bypassed. So we cannot have ball floats. And that's why when the state inspector comes out, does an inspection, you're relying on the flapper valve, we have to inspect to make sure there's not a ball float interfering with the flapper valve operation. Ball floats. Gravity only, tight connection. Also, you cannot have a coaxial drop tube, generally tied to gasoline. Why not? Well, gasoline is delivered down through the drop tube. Vapors now come up on the outside of this drop tube through the coaxial system. If you haven't listened to the coaxial, and vapor recovery system yet, what it does is that all the vapors now go back to the tanker truck through this vapor recovery connection. It's not going out through your vent system. So the product goes down through the drop tube, the vapors come up on the outside of this through your coaxial connection back to the tanker truck. Well, the problem would be there is that the ball float is bypassed because the ball float's on the vent. Well, we're not using the vent. We're using the vapors from this way back to the tanker truck, and there's nothing here to shut the vapors off from going back to the tanker truck. Good point. Suction pump dispensers have what they call an air eliminator. And how that works is a suction system pumps product. The pump is up here in the dispenser, and it requires product to be in the line and in the pump. So when you turn it on, there's product there. You can suck product up out of the tank and out through the dispenser. Well, an air eliminator there is to allow any trapped air to get dispelled, so that when you shut the pump off and there's a little bit of air in the line, because we don't want it there, because when you turn the pump on next time, if there's air in the pump, you can't suck any product. So it eliminates it. It pumps or lets the air to expel out. Well, I've yet to find a contractor to go into a suction pump system and clean that air eliminator every year. And what happens is you get a little bit of debris, grit, sand, whatever, in between that air eliminator, holding it open continuously. So that when you do a delivery with a ball float closes, builds up pressure in the tank because the air wants to get out. Well, that air eliminator is open because it has dirt in it. So now all the product and air coming out through that air eliminator under the dispenser and into the sump or into the ground. So we do not allow suction pump systems to have ball floats because nobody has ever in the past kept cleaning air eliminators. What not to do. Here's a prime example. Matt Jones, when he used to be an inspector, was inspecting a site. And this delivery company came up, put this apparatus down into the tank, started doing his delivery. So Matt decided, well, went back to the car, got out his camera, came over and took a picture. And the driver asked, what are you taking a picture of? And this is from a different location, but this is what he's taking a picture of here. All right, raise of hands. Anybody know what that is? Oh, I get a lot of people in class scratch their heads and a couple people will yell out. What it is what they call a whistle stick, used for home heating oil systems. Not allowed for any regulated underground storage tank in the state of New Hampshire. And what it does is when he's doing a delivery, it whistles to let him know the tank's getting full. Well, that's not allowed in New Hampshire for our regulated systems. Besides that, he asked, well, the overfill device for this system is a flapper valve, right, sir? The driver, yeah. The driver knew, yeah, it's a flapper valve, yeah. Okay, so Matt asked, well, yeah, you're using a whistle stick, but you're supposed to be relying on the flapper. So, if you bypass the flapper because, why? That tube runs right down through, just like I've got this inventory stick here, holds the flapper open, that won't close. See, the float comes up and it won't close. Yeah, I know that. Well, You bypassed the overfill device. Yeah, but I'm using this whistle stick. Well, it's not allowed in the state of New Hampshire. And besides that, how would you know when the tank's full? Oh, that's easy. You see this? I just look down the fill here until I see product coming up into my face. Excuse me? Yeah, when the product comes up this tube past the flapper and starts rising up here, it's coming into my face. Yes. Now, not allowed. Now, is he breathing vapors as he's doing the delivery? Yes. Is he possibly causing contamination to himself and your site? Yes. And the big thing is, did he overfill the tank? Yeah, because he probably filled it right up past the flapper valve and probably wetted the inside top of the tank. And hence, remember where I said, well, our contamination now is coming from those fittings at the top of the tank. So he probably just now contaminated your site with those possible leaky fittings at the top of the tank. So we do not allow that. Here's one that I was doing an inspection on the back side of this fence is where the underground tank, and I always do a walk around the facility to see if there's other problems that might going on. So when I walked around the fence and I saw these inventory sticks here, I looked at them and said, well, they're short, too short to, do sticking in the tank. So to me, that's an immediate red flag. What is going on? Well, what's going on is when the delivery company drives up to do a delivery, he's going and grabbing one of these sticks, put it down that fill tube, bypassing the flapper valve, so the flapper problems. Here's a flapper valve, OPW1, with the flap. Looks great. What about this one? What is this? This is actually a hose clamp that's used for piping to clamp down something. Well, I can't really show you because you're not here in class, but I'd hold this up in the air and I'll show you this clamp. What it's doing is it's pinching this flapper down, so the flap is pinched down here, now won't allow the flap to flap up, so it will never close. This one here, what's the problem over here? Well, I say this is an A-B operator problem because they didn't keep their spill bucket clean and free of water. Water built up in the spill bucket. Now it ran down between this riser tube and the fill, causing rust and corrosion, which now weep down onto this hinge. See this hinge right here? Okay, all that corrosion came down on the hinge right here, binds it up. All right, the hinge is stuck because all this corrosion. So now the float will not float up because it's stuck here vertically. It doesn't pop out like this so that it can float up. If it's stuck down vertically, it cannot go anywhere. So this overfill device is compromised. It's not going to work properly. Anyway, this is a video. And what happens here is, which won't appear with this setup, is that he pushes on the float here and it goes up. And this hinge is so dried out and corroded that it goes and it stays right up here. And he had to put his hand on it and put it down. So it's frozen either way up, all the way up, or all the way down. It did not work. Sorry I couldn't show it to you. Here's an example with that float being stuck in the up position. The flapper valve is half closed. Okay, so as soon as you started to do a delivery here, it'd slam it shut because it's already partly closed. The other major problem with this is right here. Your drop tube. It's all corroded away. And now all you see is the rust and corrosion for your riser tube. All right, so we have a failed drop tube. Other problems. Here we have a ball float. Huh? Well, kinda. We're missing the ball. Here is number 6 heating oil. And number 6 heating oil is like glue, heavy. And so it actually stuck right to the ball stuck right to the cage, and so therefore the ball won't float. And as you can see, they've overfilled many times. Here we have a ball with a hole in it. And where they manufacture these balls is, you see a little seam there, and I could show you, but we're not in class, is that it's 2 halves, and the 2 halves are held together and welded together, probably at this point here, and it causes a real thin spot, and all of a sudden you got a hole in the ball. Well, if there's a hole in the ball, then the ball fills full of liquid and won't float. Here's a beautiful one that Rob Stockman did when he was doing an inspection. They did a pre-inspection before he got there a week or so beforehand and found out they had this scenario. So they went into the office and they grabbed this and put it in here because the ball was gone. Raise your hand. What is it? Well, what it is a plastic orange. Even got the label on it, brand new. Anything wrong with this? You betcha. Plastic orange. Is that compatible with petroleum products? I can see you shaking your head. No, you're right. But it's new. It doesn't matter. Sorry. You're going to need replaced with the proper ball, or you're going to have to replace the ball float, and after 2021, you're going to have to replace with a different type of overfill device, remember. Other problems that people don't realize and think about is, here we have what we call as an ATG, automatic tank gauge cap, for that inventory probe or overfill device, and we have a cap. Well, the cap doesn't quite fit on here very well, so they put a zip tie. And the reason why it doesn't quite fit is this manufacturer of the cap is not the same manufacturer of the adapter. So therefore they don't fit together. So we just put a zip tie on it. Do you think that's vapor tight? No, it's not. Here's another scenario of an ATG cap, just how I found it. Matt Jones, my supervisor, sent me out to this site because he was getting phone calls from customers saying, well, every time we come out here and fill in my car up with gasoline, and there's a tanker truck there doing a delivery, all I can do is smell gas, and I mean, it stinks. So I went out there and did an inspection, checked, and they had ball floats. Everything looked fine, and then we opened up the whole tank field. And, excuse me, this is what we found in the ATG. The cap was off, and therefore all the vapors are coming out. So when the ball float closed and all the vapors wanted to go out the vent, it came out here instead, right at the level of this, which is about 3 or 4 inches below the tank pad. And so everybody was smelling the gasoline because the vapors were no longer going back to the tanker truck or out the vent. It was coming out here, right where the people were that filling the car, because the tank was only, this location was only about 10 feet away from where they're standing there filling their automobile and hopefully not smoking cigarettes as they're filling their car up. Luckily, nobody got hurt. FYI, just keep in mind that your underground tank is installed under the concrete or pavement, and that is probably 3 or 4 feet down before the tank is. Now, the ball float is in your tank. So that, keep in mind that if a truck driver comes in with a tank full of product, which is probably 11 feet or so to the top of the tanker truck, and then there's another 4 or 5 feet down to where the ball float is, that there's more than 11.5 feet down to where the ball float is. What was the pressure that I said for your underground tank? 5 pounds of pressure. So just thinking water without converting. So that if you're going to deliver product to this underground tank is already full because you hitched up to the wrong one that you just filled accidentally, and you started delivery. Well, there's more than 11 feet of head pressure, which means that you have more than 5 pounds of pressure on that underground tank, so it's likely and very possibly that he may split the tank open. So if you're finding some major problem going on with inventory after you've done a delivery, you may have tried to fill the wrong tank and split your tank open. So FYI, something to think about and keep an eye on. I was doing an inspection on an emergency generator tank, diesel, and I asked, "Oh, we have a ball float registered for your overfill, restricted device. Yeah, where is it? I don't see an access here to the tank because it's all grass and no place. Oh, no. Ball float's here. Here in the vent. Yeah, it's supposed to be in the vent, but the ball float's supposed to be in the tank, sir. So if the ball float is right here, that means for product to float all the way up to this point, all the way up to here, before that ball would actually close and prevent the tank from being overfilled while it's already overfilled to probably, gosh, I don't know, 120% full before the ball float even floats. That doesn't work. Here's a ball float that I had removed from an underground tank, and I think the ball float was about 6, 7 years old. Heavily rusted and corroded. Ball float, the bleed hole was corroded right through to the point where it's plugged up. The cage actually broke free. It corroded away. So they'll talk about in another module about compatibility of product. And this is one because the tank was actually fiberglass and very little metal or steel in the tank, and it was diesel. And diesel and steel, and the new product for diesel is what do I want to say? A compatible headache, in the sense that if you have a diesel tank with a little bit of water in there, the bacterial growth and so forth will cause heavy corrosion and cause a problem. So hence, hint, hint, if you got diesel tank, make sure there's no water in your diesel, because this is what's going to happen. Drain valves. Well, they all leak. And if you listen to our vapor recovery, and I explained that dust and dirt blows around, gets down here and holds these drain valves open. So if you're doing a delivery and either the flapper closed or the ball float closes, now you got vapors coming up through the spill bucket continuously into the driver's face. I was trying to do a pressure decay test for gasoline, and we were having a failure. I looked in the spill bucket here and it was all bubbling. Well, we pulled out the drop tube, and what we found here, and I put a screwdriver right through the hole, is that the riser pipe had rusted right on through. So we were actually pushing vapors out into the spill bucket. Okay, we have a sign. Doesn't belong to this same site. Anybody know what this overfill device is? It is what we call a Scully whistle designed for a home heating oil tank. And what happened here is I did an inspection. I was covering for another inspector at the time because they were on vacation. And I wrote up the site because they were getting a pressure delivery. And remember, if I said if you're doing a pressure delivery, the only type of device that you can have is an audible visual alarm. Well, they had a ball float. So I told them the ball float has to come out and put an audible visual alarm. Well, they put this in, so when Genevieve, the inspector, came out 3 years later, this is what she found. Well, that's not allowed in New Hampshire. EPA doesn't allow it. This was a site that I had found one previously that had a sign in this type of device. Well, they had properly removed that type of device, but they never removed the sign. So you want to make sure the sign also gets removed if you have a sign such as that. Now, we also had another scenario over here. Where is it? Can't see it. So if the light goes off, how are you going to see it? Don't even hardly see the sign explaining what it is. Hopefully the alarm works. Well, I wrote the site up because I could not see the light. They wrote back saying, okay, they removed the brush and now everything's hunky-dory. I went out 3 years later for our state inspection, and this is what I found. It all grown back up and plugged. So I had to write them up a second time. So I got another letter saying that they corrected the problem. 3 years later, I went out and they corrected the problem. They actually removed the stump and everything so that it did not grow back. So yay, yay. Finally, here we have a light. Great. We have the horn. Great. Except for this monitor for overfill is in the basement. Uh-oh. Well, if the delivery guy is outside filling the tank, how is he going to see the light? And possibly couldn't even probably hear the alarm. So, no. Other problems. Here we have diesel or heating oil. They filled the tank, pushed product right up the vent, out onto the ceiling. Here we have another one. Pushed the product right up out of the vent against the wall. How can that possibly happen like that? Well, that's pretty easy. Not at either one of these sites, but one similar to this I did an investigation at. And when I got there, I talked to the driver. I says, look at this. What happened? He says, well, it's not my fault. I did not overfill the tank. I says, okay, let's stick the tank. So we stuck the tank. You're right. You did not overfill the tank. So what happened? And I said, well, that's fairly easy to figure out. Is the guy overfilled the tank the time he came before you. So this guy that previously filled the tank overfilled the tank, filled product up into the vent line because he overfilled it. And then as the customer used all the product in the tank, well, there was a little sag in that vent line. So there was a plug of oil that got stuck in the sag. So when you came up and hitched onto your tank and started doing the product delivery, your product went into the tank, the vapors were going to go out the vent. Well, since now the vent line was plugged with the product from the previous guy, it takes that plug of oil and just blew it right out the vent up onto the ceiling and on the wall. That's what happened. So it was the previous guy that filled the tank, had overfilled the tank, causing this release. Here we go. We have all kinds of product running down the side of the building. And it was at a school. This is a brand new addition that they just put on. And they're starting to do the cleanup. Whoopee, 35 gallons. So what? Well, I said they started doing cleanup. They've yet to dig all the way down the wall, foundation wall, under the footing, under the gymnasium floor. This was a brand new addition. So it could be extremely expensive to clean up. What I want to imply as you A/B operators, a lot of municipalities, schools, whatever, go out to bid for product. In your contract, make sure you put in the type of fill that they can do to fill this tank, fill your tank. In this particular case, they had listened to me, and so in their contract, they had put to be gravity filled only. No pumping and filling the tank. Well, in this particular case, the tank company that came to do the delivery actually did pump product into the tank, overfill the tank, and push the product out the vent. And in this particular case, the oil company ended up paying for the cleanup because it was in the contract. So keep that in mind. If you're going out to bid, you got to make sure what type of delivery that you can take. Another investigation I was sent out to is here's this guy pointing right down to what we call as that automatic tank gauge cap and your inventory probe. And this is just how we found it when we pulled the cover off. There's a bunch of gasoline here in the tank. And what happened is they had overfilled the tank and this probe just floated up with enough force and the cap was not on tight. It actually popped the cap off and blew gasoline into the sump. They were lucky in the sense that there was a sump because a lot of these ATGs, as I showed you in the previous pictures, were just in this little manway that had dirt all around the outside of it, and all this product would have gone strictly into the dirt. How could this possibly happen? Well, this was a site that was getting back into operation. Been in temporary closure for a while. Somebody had bought it, decided, okay, we want to get in business, get operating, and start making money. So let's fill the tanks. Well, they didn't do proper procedure regarding to temporary closure and how to bring a temporary closed tank system back into operation. And if they had, they would have tested the overfill devices and determined that the overfill devices were, like I'd shown in previous pictures, the float was stuck down and the hinge was so corroded it wouldn't work. So when they came and filled these tanks, the valve never worked. The other problem was they did not go inside and look on the wall for any information about these underground tanks. The driver came to fill 3 10,000 gallon underground storage tank. If he had, or the owner had looked to determine what type of tank that they were filling, on what should be posted in the facility is what we call a tank certificate. It tells you what product, what tank number, and the diameter, and how many gallons it holds. Well, if he had looked at the chart before he did the delivery, he would have not had this problem, because the certificate chart said these were 3 8,000 gallon tanks, and he came to fill 3 10,000 gallon tanks. Somehow trying to stuff 10,000 gallons in an 8,000 gallon tank doesn't work, and this is what happens. Remember, we're trying to prevent overfills. So you want to register your overfill device. If your primary is your flapper valve, we need to know about it. If it's a restrictive device, a ball float, or the audible alarm, you need to know about it. Us inspectors need to know about it. And of course, the delivery company needs to know about it. And if we register it, anybody, including the delivery company, can go online and find out what's registered as the primary overfill device for your underground tank. So we want to make sure the device works. That's why we inspect them every 3 years. The driver needs to know, is it a complete flow shut-off device so he can put in 95%, or if it's an audible alarm that he's relying on, so he knows to look for a light and horn and he can only fill it 90%. And of course, you need to know what type of device in order to know how much product to order. Here's a sign that was installed after we did have a site that had contamination. They put this huge sign up at the fill. This is 1,000 gallons, gravity drop only, and no pumping allowed. And to this point, as far as we know, is they've never had another release or overfill. They went above and beyond. We have a couple of cheat sheets, what I call, that we put together to tell you the type of overfill device you can have, such as audible alarm, flapper valve, or ball float, what kind of method that you can deliver to it, such as a pressure or gravity, and the type of connection. Is it a loose or tight connection? Here we have a flapper valve. Can we do a pressure delivery with a flapper valve? No. What do you mean no? No, we can't. Really? All right. So this is what this form is for, to determine these things. And great to have this on a delivery truck that they can carry around, or if you're a facility that has multiple tanks, multiple locations, etc. So the second one would be is what type of pump system? Is it a pressurized, or do you have a suction dispenser system? And what flapper valve? And do you have gasoline with vapor recovery? Is it a 2-point system or a coaxial? So these are some ways to help you determine which type of overfill device works and does not work. Why do we have the device? Of course, we don't want overfills. We do not want to contaminate the site, of course. And what is the delivery method? We had 2 different types. What were they? Oh, yes. We had the pressure delivery and we have the gravity delivery. Those are the 2 methods that are currently in use. Pressure delivery, which device has to be used? Remember I said pressure deliveries, hint, hint, the only device that will work would be audible visual alarm. Why is that? Well, if you're doing a pressure delivery with a flapper valve, he's pumping in, pumping in, pumping in, pumping in. Well, the flapper valve closes. He's pumping in, pumping in, pumping in. Something's going to break and explode. It does not shut off the pump. Okay, and the same with a ball float. If the ball float closes, he just keeps on pumping and pumping and pumping until something overfills. Flow shut-off device, maximum. How full can we fill? Hint, hint. What's the percentage? Complete flow shut-off is 95%. Whereas the restrictive and the alerts is at what percentage? 90%. Hint, hint. Because we got to give that driver some time to shut off the valve to the tank system. So 90% for restrictive and alert, 95% for a complete flow shutoff. Who's responsible for the overfill that just happened on your site? That would be you. You own the site. You own the product. You own the contamination. It's your responsibility. Okay. Granted, there might be some responsibility by the delivery company, but ultimately, contamination is on your site. You own the contamination. Nice picture from EPA. Driver's doing a great job. He's watching what he's doing, right? Not quite. I think he bypassed the overfill flapper overfill device, and now the product's running up here and running down here on the concrete pad and pavement. Here's a site that Matt Jones talks about, a horror story usually. This was by a previous owner. I was doing a delivery. I was doing a field inspection, and he drove up to do a delivery. We talked for a while. He set up to do a delivery, connected all up. Then he proceeded to sit down and do the delivery. And I says, come on, I'm a state inspector, so I had to take a picture. Is he paying attention to the delivery? Could it possibly have an accident happen? You betcha. I could not believe that. What do we have for questions? Well, I'm sure you may have some questions, and hopefully what we'll